So in today's video I want to prove the derivative with respect to x of the sine of x. And to do so I will need two formulas which I have written at the top. The first is the definition of the derivative, which is the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Hopefully you're familiar with this. We use it to prove all of our derivatives. We used it in the tangent line problem when we showed what a derivative is and what it means in respect to a graph. And really it's just our difference quotient taking the limit as that difference goes to 0. The second formula we'll need to prove the sine derivative is the sine sum of angles formula, which I have written there. Sine of x plus delta x equals sine x cosine delta x plus sine delta x cosine x. So to begin, let's go ahead and write out our derivative of the sine of x is going to be equal to the limit as delta x approaches 0 of the sine of x plus delta x, which is simply our f of x plus delta x, minus the sine of x, which is our f of x, all divided by delta x. Now from here we'll use our sum of angles identity I have written above, so it will be the limit as delta x approaches 0 of the sine of x times the cosine of delta x plus the sine of delta x times the cosine of x, and then all of that minus sine of x, because we just took this first part as our sum of angles minus this sine of x on the end. All of it is still divided by delta x, and we just took sine of x plus delta x and used this formula to get to here. Now it may look like a long jumbled up mess at this point, and rightfully so, but you'll see in just a moment after I sort this out that it will begin to take a form you hopefully recognize. So we can rewrite it as the limit as delta x approaches 0, and I want to group this first term and this final term together. So it will be the sine of x times the cosine of delta x minus the sine of x all over delta x, and then plus our middle term there, the sine of delta x times the cosine of x over delta x. Now from here I want to rewrite it as the limit as delta x approaches 0. I'll factor out a negative sine of x, and that will leave me with the negative cosine of delta x minus or plus 1 all divided by delta x, and I'm simply factoring negative sine of x out of this whole term. And likewise on the second portion I'll factor out a cosine of x, and I'm left with the sine of delta x divided by delta x. Now you may not see it quite yet, but hopefully it will become clear with the next step where we're going with this. I'll rewrite it, splitting it into two limits. It's the limit as delta x approaches 0 of the negative sine of x times, rewriting the top portion here as 1 minus the cosine of delta x over delta x, and then writing our limit separately on the other side, plus the limit as delta x approaches 0 of the cosine of x times the sine of delta x over delta x. And now I hope that you can see this is our squeeze theorem identity that we've proven with limits. The first one here, 1 minus cosine delta x over delta x, as the limit as delta x approaches 0, it's simply 0. And for our second one here, the limit as delta x approaches 0 of sine of delta x over delta x will give us 1. So we can then simplify this to the negative sine of x times 0 plus the cosine of x times 1. Well, anything multiplied by 0 is simply 0, so that goes away, and we get our final answer, that the derivative with respect to x of the sine of x, which was where we began this problem, is equal to the cosine of x.